That's what's inside your Lexmark laser printer. The powder is electrostatically charged. It's developed as a full image onto a roller. Then the full image is deposited onto the substrate. And that's quite important. Potentially be very, very fast, over 2,000 pages per minute. It's a dry powder, so there's no liquid solvents, unlike inkjet printing. Layer thickness from 1 to 50 microns, and up to 2,400 dpi at the moment. And as with most things in printing, each year the dpi increases. And the ability to deposit 4 or more materials simultaneously. So it has an angle. Laser printing has an angle in this business. Okay, this is a very early test rig, so I apologise a little bit. We have a new test rig which is over at MCP, and I hadn't realised we were allowed to show it until William said we had got approval. It was too late now to get the video on for it. But this is a standard Lexmark printer turned onto its edge. It's depositing a layer of material. So that's a standard toner, and it's being fused in the infrared heater going around the process. And that basic principle is what we're now developing in the industrial unit. By the way, Lexmark don't like being tilted on the side, just out of interest. So this at home. Lexmark, there's a big peak of returns of laser printers in the East Midlands. So that's as much as I'm prepared to say. But you have to try these things. That's what research is about. We're moving away from that. This is a desktop printer. We're now moving to an industrial print head, and I can't show it you because I haven't got permission, but it's a completely different animal. It's as big as the laser print, Lexmark printer in totality, just the printer alone. And we can use it for printing a very wide range of materials. It's a robust and rigid system. It's got like a big hopper you open up, pour the material in. It's not a sealed cartridge. And that's been developed, say, the test rig itself has been developed with MCP Two Technologies and CTG. And I know that William showed some pictures and his presentation of an artist's impression of what it looked like. But I can say that the frame and everything else is now being assembled in Stoke-on-Trent. So hopefully we'll have the first British-born machine. So I've used a wide range of materials, because even though we can print polymers with a standard laser printer, they're very brittle. So we have to develop a whole new range of flexible materials, flexible rubber for the helmet, polyethylene for making prostheses, and then support materials which we can reuse. So we looked at waxes and some soluble acrylic materials. And strangely, the process is quite flexible. We've managed to almost print everything we've tried. And these are some of the samples we've made. You might say, well, not very impressive, but they probably represent the best quality samples of any research group in this field in the world. And there are 2 other groups in the States playing around with laser printers. You can see their polyethylene toner. The quality is fantastic because you're pressurizing and fusing at the same time. They're not like, okay, I'll be careful what I say because they also here, but they are better than laser sintered samples because of that pressure. And we have built, albeit 3 sets of layers on top of each other, and we've printed other materials, and we also printed functionally graded materials from styrene to high density polyethylene. So that everything's there, we're just now waiting for our wonderful new test rig. Okay, I hope I haven't completely confused you with the processes. Klaus now has until 1 o'clock latest to do all of the materials.